Let's now talk about system calls. Actually, this is not in the syllabus, GATE syllabus, it is not mentioned, but then finishing operating systems without talking about system calls it doesn't feel good. So I'll just finish it off, and it will not take more than 2 hours or so. It is a very small topic. Even though it might not be asked in GATE, just try to watch it, it will give you some more insight into this subject. Okay, so let's say this is the main memory. Okay, and assume that some part of the main memory is being occupied by operating systems, and whether this contains the total operating system or it contains only part of it, that is system dependent. Some operating systems feel that only kernel should be present in the main memory, and whenever required other modules should be loaded into the main memory on demand. That is what some systems feel. But just to simplify the things and keep it easy, I want to assume that entire operating system is present in this part. Okay, and say a process is running, a program is loaded and a process is created, and a process P1 is loaded here, and it is executing. Now, as again, if you see this, it is also an assumption that I am using the contiguous allocation and the entire process is loaded here. So I didn't use any paging or anything. Just to keep it simple, I am using the contiguous block allocation. Okay. Now, in general, what happens is every process will be allowed to access only certain range of memory, and it is not allowed to access other parts. So why is this so? We wanted to provide the protection. So a process running should never ever access any memory other than what is actually allocated to this. So this process should only access these memory locations. It should not access this memory location, or let's say some other process here, some other process here. It should never access that. Okay, but then if this is so, every user process will be having very limited powers, which means a user process will not be able to do much if this is the case. The reason is most of the things in the system are actually maintained by or managed by operating system. For example, if your program wants to read something from the keyboard is under the control of operating system, right? And in order to read something from the keyboard, the actual code that has to be executed will be present inside the operating system somewhere. Similarly, if you want to write something onto the monitor after processing, this process wants to write something onto the monitor. Again, monitor will also be controlled by operating system, and so you have to invoke or execute some part of the code which is present in the operating system in order to execute that, in order to accomplish that thing. Either you want to read or write a file, right, or you want to have a hard disk access. Everything, almost everything will be present in the operating system code itself, and you have only limited power as a user, right? So what you should be doing is, if you need anything, you are supposed to call that particular module which is present in the operating system. Now, whenever you want to go into the operating system and execute that particular module which is required, we call this one as system call, raising a system call. System call is exactly same as the function call, but then in system call you will be trying to call the function which is present in the operating system. In general, a function call can be anything. Either you can call a function which is present in your computer, in your process. Let us say this is a user defined function, right? If you are trying to call this, that is also a function call. But when you are trying to call a function or a module which is present in the operating system, that is generally called as system call. Now, various systems, they have different methods of implementing the system calls. Some systems have given the control directly to the program or higher level program, and you can write the instructions in the higher level program and you can directly call that particular system. For example, in Linux, if you are writing a C program, you have the function calls write, and you have the function calls read, and you have the function calls open, close, right? So all these function calls are directly implemented in the higher level language. If you include these lines in your higher level language program, you can directly call them. Similarly, some systems, they use an indirect way of calling the system, you know, these functions which are provided by operating systems. So what they do is they will have a system library or the local library, and the library function call or is going to implement the system call. For example, in C programming you might have seen printf, right? So when you execute printf is a library function, right? And the code related to this printf will be loaded along with your process into your process. Therefore, you are not going to write the code of the printf, it is provided as a part of the library function, and now this library function will be loaded when your process is loaded, right? And whenever you call this printf internally it will call write. Okay, so this is how a user will call a library function, and now the library function will make the system call. Got it? So there are various ways. Some people say, you know, some systems use assembly language instructions. For example, if you try to call, let us say this is the higher level system call, when you compile it, a assembly level language code will be generated, and that code will cause the operating system to be invoked, right? And also, you know that whatever you are running as a process, you run this in the user mode, and whenever you want to execute the code in the operating system, it will be run in the super mode, right? A super user mode. Okay, so anyway, that mode changing is there, and then context switching will be made. So what are the things that you should be remembering here is, whenever a process needs something from the operating system, the only way it can get it is through system calls. And how to make the system calls? There are various methods. Sometimes, see, again, this is depending on the system implementation. Therefore, there is no standard way. From system to system it changes. Some systems, they use assembly language instructions, therefore you are supposed to include those instructions and automatically it will be called. And some higher level languages have the facility of including the higher level language instructions, which will lead to a system call. And some higher level languages, in C we can directly write and read, or you can directly call printf, right, or scanf, something like this. And some of the languages, they wrap the system calls inside a library function, and so user will be calling the library function and the library function will call the system call. Got it? And anyway, just like the way a process switch is happening, just like the context switch, here also a context switch has to happen. So which means when you are trying to call a function here, your entire status, right? So the state of the process will be saved somewhere for the later restoring. So you go there, you do the complete execution, and again you come back and execute from where you left. Similarly, one more issue that has to be answered here is parameter passing. For example, if you are trying to write into some file, say you want to write into some file in Linux, in a system like Linux, everything is a file. A monitor is a file, a keyboard is a file. If you have to write something onto the monitor, you are supposed to use the system called write, and for this write you are supposed to send the parameters like what is the file you want to write and where you want to write and what is the size of the message and what is the message, like that. Some parameters have to be passed, isn't it? If you are trying to write something, some parameters have to be passed for the function, right? See, from here if you are calling write, the parameters have to be passed. And how are we going to pass the parameters? Again, it varies from system to system, and there are various ways of calling it. So one way of passing the parameters is by using registers, which means this method says that whatever parameter you want to pass from the user program to this program which is present in the operating system, you place them, all the parameters, in the registers, so that when this particular instruction gets executed, starts execution from here, they will automatically fetch the operands that are being passed, parameters that are being passed from the registers. But the problem with this method is, as you know, sometimes our parameters may be bigger or the number of parameters may be more compared to the number of registers available. Therefore, this is not widely popular method. This has been used initially, but later people are not using it. And the second way is, you can pass the parameter by storing it in a block of memory, right? So you can use memory, which means, as we have seen in maybe CO or some other places, we are going to store certain values in certain memory locations, fixed memory locations. For example, a system may say that we are going to save all the parameters that are being passed at address number 0. Right? Let us say some space is allocated to this, and let us assume that this space is allocated in such a way that there will be no overflow, a kind of stack kind of implement. Let's not talk it as stack. Some memory location is some memory is fixed and allocated to that. Now, when you want to pass the parameters, you store all the parameters there and say that this part is available for you to access. You just save it there, and then you call the system, right, operating system, and it will take care of it. And some other implementations say that we are going to use this stack. So stack implementation is same as how you do the function calls. So what we do is, in this stack we are going to write all the parameters in some place and then call the system, and after the operating system has used up all the parameters, it will just free up the space and get back to you. Got it? So we are going to call the operating system, and also we are going to pass the parameters. Now what will the operating system do? It will perform the act, whatever you are trying to do, it will just finish it off, and after finishing it, it will again come back. Control will be returned to the process. So anyway, there is certain overhead here. You are supposed to do context switching because you are in some user mode executing a process, and everything that is being done has to be stopped, and the entire context of the process, you know what a context is, we discussed it many times. So the context of the process has to be saved somewhere, and you have to go into the system mode, and again you have to change the mode. So from the user mode you have to change to system mode, and again after finishing it, you are again supposed to restore the context, right? So which means you have to restore the process by loading the context, all the registers and everything, program counter and all, and again you are supposed to do this. Therefore a context switching is involved, and also we are going to go from user mode to system mode. So there is of course a overhead, right? In case if this particular function is being provided as a part of the process itself, there is no need of context. That is the main difference between a system call and a normal function call. If you talk about a normal function call, your function will be present in the same address space to which your process is given permission to access. In that case, you need not switch the context. You need not go from user mode to system mode. You can simply start executing it. But here, in case if this, since it is present in the operating system, you have to perform all this. But then why this headache? Why don't you directly give every process the access to operating system, so that whenever required it will go there, execute it and come back. The problem is such a thing is, we don't want every user to access and modify the code of operating system. It will raise lot of protection issues, right? So there will be security and protection required. So that is why we want to go into this system mode and do it in a protected manner, right? And also, since this code is shared by many processes, we want to have some mutual exclusion. Even if you keep it in the read mode, we want to have some mutual exclusion, and there are various things there. Okay, so after doing a lot of experiments, they found out that this is the best way to provide the access to resources for a user process. If you want any resource, go through the system call. Okay, so next we shall discuss what are the various types of system calls that have to be supported by any system in general. Okay, fine.